We're once again talking about Comet Atlas, and this time there are new updates and fascinating discoveries. For those unfamiliar, Atlas is the third interstellar object, or interstellar comet, discovered in July 2025, and ever since, scientists around the world have been racing to study it. Recently, the comet completed the most intense part of its journey, perihelion, the point where it comes closest to the sun. Unfortunately, during this critical phase, it was completely hidden by the sun's glare, making it visible only from planets like Mars. We actually discussed those Martian observations in a previous video linked below, though honestly there wasn't much to see. Still, this didn't stop space-based observatories from tracking the comet, because events like this are incredibly rare. Now that Atlas has re-emerged from behind the sun, researchers have another chance to observe it, and the first new discoveries are already coming in. But today we're not revisiting the basic details, like its speed, size, or estimated age. Those have all been covered before. Instead, we're focusing on the latest findings, the ones that are surprising, mysterious, and deeply revealing about the comet's true nature. What makes these updates so thrilling is the fact that Atlas is believed to be over 7 billion years old, possibly even older, a cosmic time capsule, shedding ancient material that gives us unprecedented insight into the early history of our galaxy. So, what exactly happened during perihelion, that dangerous moment when Atlas brushed past the sun? The answer arrived on October 29th, just a few days ago. At its closest point, the comet was roughly 220 million kilometers from the sun, about the same as Earth's distance, only slightly farther. From Earth, though, it was invisible, forcing astronomers to rely on space-based instruments like SOHO and GO-19, telescopes designed to block out the sun's brightness and study its outer atmosphere. This time, they became the sole witnesses to Atlas's perilous passage. And what they discovered was nothing short of astonishing. Did the comet survive the sun's fury, or was it obliterated by waves of plasma? Some scientists even suggest that its possible disappearance or orbital shift could reveal something unusual in the sun's magnetic field, a mystery they're now racing to understand. But then came the first major revelation that stunned the scientific community. Between October 20th and 25th, just days before perihelion, Comet Atlas suddenly brightened at an extraordinary rate. Just before perihelion, between October 20th and 25, Comet Atlas suddenly brightened at an astonishing rate. In a short span, it became more luminous than ever before, so bright that if someone had been observing from Mars, the sight would have been breathtaking. What stunned scientists even more was the sharp intensity of this brightening. Unlike typical comets that gradually glow as surface ice vaporizes into gas, Atlas's light surge followed an inverse power of 7, an extraordinary measurement indicating something highly unusual was occurring on its surface. Researchers quickly documented this phenomenon, but because it was so recent, no one could yet explain what caused it. One fact stood out. The closer Atlas moved toward the sun, the more its emissions skyrocketed. Adding to the mystery, astronomers noticed a color shift. The comet began glowing bluer than the sun itself. This marked a major turning point. The blue tint suggested the release of volatile molecules like cyanide or ammonia, which emit bright visible light. These gases' vivid blue glow outshine the reddish reflection from dust, giving Atlas its intense, otherworldly hue. Curiously, this was already the third recorded color change for the comet. Weeks earlier, it had glowed green, and scientists still don't know why. This ongoing pattern revealed that Atlas is extremely active, ejecting material at a rate far greater than most comets in our solar system. Such volatile behavior supports the growing theory that Atlas is an ancient interstellar traveler, a remnant from the outer edge of a long-lost star system, drifting through cosmic darkness for billions of years before its fateful encounter with sunlight. A striking image from the Very Large Telescope deepened the mystery. It showed Atlas's gas and dust cloud shifting shape constantly, forming a faint stream that seemed to stretch directly toward the sun, as if the star itself were pulling and sculpting its outer layers. Now, scientists are asking whether this is a normal solar interaction or evidence of some unknown magnetic phenomenon at play. The latest James Webb Space Telescope data added yet another layer of intrigue. Viewing Atlas in infrared light, Webb confirmed that its surface has been battered by extreme radiation over its long interstellar voyage. For billions of years, cosmic rays from across the galaxy have bombarded its surface, grain by grain, molecule by molecule, gradually altering its chemistry through countless reactions. The result: a comet that is not just old, but possibly one of the oldest surviving messengers of our galaxy's hidden past. This constant bombardment of radiation created a dense, ancient crust on Comet Atlas, estimated to be 15 to 20 meters thick, about 50 to 65 feet. Scientists see this layer as a geological record of the universe, preserving the imprints of every impact and burst of energy over billions of years. Within it may lie chemical clues from the earliest days of our solar system. If humans ever set foot on Atlas, especially while it's far from the sun, they wouldn't be standing on a lifeless block of ice, but on a living witness to the universe's earliest history. The comet's surface has been sculpted by cosmic storms for eons, and researchers believe it could hold the key to understanding how the raw materials of the cosmos evolved. Even more fascinating is the possibility that organic compounds, altered by cosmic rays, might reveal how life could form elsewhere in the universe. Atlas, therefore, isn't just a frozen traveler drifting through the void. It's a memory of creation itself, carrying the untold story of billions of years that sunlight is only now beginning to illuminate. This ancient exposure also helps solve one of Atlas's biggest mysteries: its unusually high carbon dioxide content. Early readings revealed CO2 levels far beyond expectations, baffling scientists for months. But new infrared data from the James Webb Telescope finally offered an explanation. As Atlas roamed the galaxy, constant cosmic radiation gradually transformed its surface carbon monoxide into carbon dioxide. Over billions of years, this slow but relentless process enriched its crust with CO2, producing the unique chemical signature now detected by Webb. For astronomers, this finding redefines how we understand cometary chemistry. It shows that the gases and ices comets release are not pristine relics of the early universe, but rather materials reshaped by eons of radiation. In short, what we observe today is not untouched matter, but cosmic material rewritten by time itself. This revelation raises another tantalizing question. Could untouched ancient ice still lie beneath a hardened outer shell, holding the true record of the comet's birth? If the sun's heat during perihelion melts part of the crust, it might expose those hidden primordial layers, giving scientists their first glimpse into the comet's original chemistry and possibly its home in a distant star system. Adding even more intrigue, researchers recently found that Atlas contains slightly more nickel than other known comets. Though still under study, this suggests that different star systems may form with varying levels of heavy elements, opening a new path for exploring how planetary materials differ across the galaxy. In that sense, Atlas is far more than a comet on a solar journey. It's a cosmic time capsule, preserving the chemical evolution of the universe itself. Each new observation brings us one step closer to understanding how the building blocks of life and worlds have transformed over cosmic time. A recent study has revealed an intriguing new perspective on why interstellar comets like Atlas may hold the key to understanding the origins of planets. These icy wanderers traveling vast distances between star systems are not just cosmic visitors. They could be the missing link in the long-standing mystery of planet formation. Traditionally, scientists have believed that planets are born through countless collisions among dust grains and rocky fragments orbiting young stars. Over millions of years, these tiny particles stick together, forming larger bodies that eventually become planets. But this model faces a critical challenge known as the meter barrier. Once particles reach about a meter in size, they tend to bounce off each other or shatter rather than fuse, halting growth and raising a fundamental question. If the process stops there, how did entire planets ever form? The new theory suggests that interstellar comets may have provided the solution. These ancient objects, ejected from their original star systems billions of years ago, travel endlessly through space until they encounter new, young stars surrounded by swirling disks of gas and dust. When one of these comets passes close enough, the star's gravity can capture it, turning it into a seed core, a stable nucleus around which surrounding matter can accumulate. This would allow dust and pebbles to gather far more efficiently, bypassing the meter barrier and triggering the rapid birth of planetary embryos. If correct, this theory implies that planet formation is not an isolated process confined to one solar system, but a shared cosmic exchange, where comets from one system help sow the seeds of worlds in another.